Hi. So today I wanted to talk to you about an idea that I've been thinking for quite a while, that is local inference. So basically, the idea behind local inference is that instead of your models for chat or code completion running on a server, they're running on your local machine itself. And this has two interesting properties, I think. One is that hopefully this should be, in terms of latency, a lot faster because it's just running on your machine, and it's theoretically just outputting the tokens from your machine, so it should be quicker. And then secondly, it should be better in terms of security because the your code or any keys that you have in your code are not exiting or egressing out of your network, right? And essentially it's just operating based on what you have. So I tried to POC these ideas, and the first thing that I came across was transformer.js, where you can essentially just like the Hugging Face transformer library that you have, which you use in Python, you can actually use that right from JavaScript. And the way you do that is you use these Onyx models, and these Onyx models are basically you could use any PyTorch or TensorFlow model and convert it to this Onyx format, which is kind of this platform independent format that you can use. Um, so Transformer.js has got some really interesting applications where you can run these models right from JavaScript, and there's some great examples, in fact, on the website as well. Um, so I decided to try that out, and the way I tried that out was I actually wrote a Node.js program that all it does is it gets completion for some fractions, some snippets of code that are provided. But all it's doing is running this local model, right? And what I did was I converted one of the smaller code gen models, which is Salesforce Code Gen 350M Multi. I converted that to the Onyx format using this small little script that I wrote. And so all it does is really converts the model from the current format to the Onyx format. And then from there, you're actually able to just use that. Using the pre-trained model, I'm actually able to just, if you see here, I'm able to generate completion. So if I run this, what you'll see is that it will go ahead and start node, load up the model as it does, and that loading up the model is pretty quick because I think it's about, it's not a very large model as such. Let me actually pull up the model to show you the spec as well. So the model is this one here, and it is about 797 MB. So it's not very large at all. It's really used for code gen. It's an interesting model because it has some interesting tokens that it supports. So if you can see, it's auto completed some of my code here. So app equal express and use body parser and this primes function as well. It started to complete. And of course, it can't generate as many tokens as we want. It's quite small as far as the model is concerned, so it's not able to really take a lot of tokens. And the second issue I found with this approach was the fact that the Transformer.js library does not really work with it does not really work with our pipeline and ES build and language servers. I had a lot of problems actually integrating with that. So the second idea that I came across was actually using Ollama. So Ollama actually is kind of like, the way I describe this is like Docker for large language models. So you can actually run any, so I can do Ollama ls to see which are the language models that I have. You can see I have two of them here. So I've got CodeLlama running and DeepSeek Coda. And so these two models which I'm running locally right here, and you can see the size of these models as well. And then I can actually just grab a prompt to these by saying Olama run and let's say CodeLlama, and that just gives me access to the model itself. So it opens a prompt to the model, and I could say and as you can see, it streams the inferences through, and you can see that it actually auto completes what I wrote there, right? So that's running CodeLlama locally. So the great part about this is that it also provides an API. So I can actually just curl into this endpoint for generate and say, hey, can you auto complete the following code for me or whatever, and then it would actually give me that completion, right? It provides this local API, so anyone can run Ollama and just download a model and start working off it, right? And there's a completion. So let me show you what that looks like. So what I've done is I've actually gone into language server and I've implemented this for both streaming. So I've created this new local inference API, which then gets both streaming suggestions and also it gets code suggestions both from your local machine. Right, so it's just calling this local endpoint to actually get both suggestions. And I'm able to, and all I've done is really, I've used the wonderful, the suggestion client interface actually. So I've got this suggestion client local, which so I just route it to the suggestion client when an inference is made, when the feature flag is switched on essentially. And in the language server side, I've got this feature flag that defines which inference and which inference model, right? So let's see this in action. Let me pull up this example here. So I've got this here and I have set, I've enabled the feature flag for local inference and also set my local inference model to Ollama. So now if I go ahead and do that, it should hopefully start streaming suggestions. As you can see, it starts auto-completing and streaming the suggestion right away. It's creating all the routes pretty quickly, right? So there's no latency literally. And it just had to change a few lines of code to support local inference. As you can see, it goes on. It generates quite a lot of tokens, and it's still going. Okay, which is pretty cool. But the second thing I wanted to also show you is that I can even switch models. So if I if I wanted to use DeepSeek Coda, I could just switch that by using the different inference model, and I can then go here and then hopefully it should start streaming. Now this one has given me some extra text, but nonetheless it is streaming the suggestions as expected. So that's local inference. An interesting thing could be that we could offer this as a free service to customers, where they could, if they want to run their own model and connect GitLab workflow to that, they could, just to try out what code suggestions could look like. Of course, these models are never going to be, or at least at the moment, are not as good as some of the hosted models that we use, and so customers could always upgrade to the hosted version when they want to, and they could try it out using this local inference method. So that's it for me. Thank you.